For this video, we're going to do some more practice with the product rule for exponents, but we're going to work with some harder problems. So remember, our product rule tells us that as long as we are multiplying things with the same bases, we can just add the exponents together to get the new exponent. So in these problems today, we're going to have multiple different bases, meaning like if we look in this first problem, I have x's and I have y's as my bases. The important thing to remember is you can only combine the exponents of bases that match. So when we do this first problem, we have x to the fifth, y to the third, times x to the second, y to the eighth. So I'm just going to go letter by letter, and the first one I'm going to work on are my x's. So I have two x's. I've got x to the fifth, and I have x to the second. So I am allowed to combine the exponents of those two to get my new exponent. So if I do 5 plus 2, I get 7. So my new exponent for x is going to be 7. Now I can move on to the y's. I have y to the third, and I have y to the eighth. Those are allowed to be combined because they both have y as their base. So I'm going to use my product rule, and I'm going to add those exponents together to get my new exponent for y. So 3 plus 8 is 11. So I have y to the 11th. So my final answer would be x to the 7th, y to the 11th. Let's try another problem that has even more levels to it. So let's do x to the second, y, z to the fourth, times x to the third, y to the sixth, z to the second. So now I've got 3 letters, but the approach is still going to be the same. Focus on one letter at a time. So the first letter I'm going to do are going to be my x's. So I'm going to add together the exponents for my x's. So I've got 2 plus 3. That's going to give me 5. So my new exponent is x to the fifth. Now we can move on to our next letter. Y's are up next. So I have y and y to the sixth. So don't be fooled here. This y that's all by itself, a lot of kids will make the mistake of, or a lot of people will make the mistake of thinking that's y to the 0 because nothing's written there. But if it was y to the 0, it would actually say y to the 0. In math, when we don't have that number written there, it's really 1. So that's like saying y to the first. So I can add together my exponents for my y's. So I've got 1 plus 6. We'll add those together to get our new y exponent, which would be 7. And now we can do our last letter, which is z. So I have z to the fourth and z to the second. Same thing. I can add together my exponents, 4 plus 2. So now I will have z to the sixth. The important thing is you just take it one letter at a time. You cannot combine exponents from different bases. If we're using the product rule, it means they have the same base, then we can add our exponents together. All right, let's do one more example. We're going to do one that has a negative exponent in it because you could see those. So this one is x to the third, y to the ninth, times x, y to the negative 1. So same deal. I can only combine the same letters together. So I'm going to start with my x's. I've got x to the third and x. We remember this x is all by itself. Sometimes people make the mistake and think that this exponent belongs to both of them just because that's the closest exponent they see, but that's not it. It has its own exponent, even though we don't see it, it's 1. So we're going to combine our exponents, add those together to get our new exponent. So that would be 3 plus 1 gives us 4. And then we can do our next letter, which is y. So we've got y to the 9th and y to the -1. So we know our rule tells us that we can add together our exponents. In this case, our exponents are 9 and -1. Okay, so when we write that, right, it would be like saying 9 plus -1, which is the same thing as saying 9 minus 1. So our new exponent for y would be 8 because we had that -1, so it actually went down. So our final answer for there would be x to the 4th, y to the 8th.